Okay, I guess it's pretty much the time. So thanks everyone for coming. Today we'll be having Dr. Vrushaly Shinglot talking about her journey, finding the passion of mathematical journey from academia to industry. Thank you.
Thank you so much for introducing me. Hello, everyone. First of all, thank you so much for coming to hear about my journey. I will be talking about how did I find my passion of working in mathematics. I will briefly share how I started being good at mathematics to, making it actually my career and finding an industrial job at the end of it. So let us start with my academic journey. So this year I came to know about this really interesting Japanese concept of ikigai. If you have heard about it, this literally translates to a reason for being. It talks about the integration of personal fulfillment with professional aspirations. So according to this concept, your happy place lies at the intersection of four key components. One is what you are good at. The other component is what you love doing. The third one is what the world needs. And the final one is what you could be paid for. So looking a little bit deeper into each one of this. So by what you are good at, what we mean is you need to identify the natural talents and areas where you excel. Coming to the love part of it, here we need to introspect about what brings you joy and fulfillment. Third one is what does the world need? So we need to reflect on the real world problems that make you feel passionate about solving. And finally, what you could be paid for. So here we need to evaluate our qualifications, education, experience for the potential roles, right? So when I learned about this concept, that made me introspect my whole journey, and I realized how I have actually used it at some points or at some milestones in my academic journey. So here I'm presenting an insight into my academic journey, relating it to the Ikigai framework that we saw earlier. So when I graduated from high school, I identified that I had a natural tendency for mathematics. I felt that I was good at mathematics. Thinking about this, I decided to pursue my Bachelor of Science in Mathematics from a university in my hometown called the Maharaja Sayajirao University of Baroda in India. During my undergraduate studies, I observed the significance of mathematics in diverse areas, such as, in optimization, which could be used, in operations research. There is cryptography that has relevance in, the debit cards or any other credit card we use in today's world. Linear algebra has many diverse applications, not only in physics, but other parts of engineering as well, right? Um, Apart from this, in my undergrad, I also realized the similarities and the differences between pure and applied mathematics. Ultimately, what this made me realize was that, I am more passionate about applied mathematics. I have a love towards applied mathematics. There comes the second key component of the Ikigai framework, right? And the reason of my natural tendency towards applied mathematics was the real world applications, that are there of mathematics that we learn. And therefore, I decided to pursue my Master of Science in Applied Mathematics from the same university with a focus on industrial mathematics. So during my master's, I got opportunity to take up a diversity of very unique courses, starting from finite element methods to image processing to neural networks and whatnot. All of these courses, they had, some sort of an application or an implementation in various industries, right? My curriculum during my master's also allowed me to take up some hands-on projects from different industrial areas, such as I did a project from civil engineering, I did a project from chemical engineering, and so on. So overall, this curriculum really helped me solidify my interest for computational mathematics. And here comes the third aspect, what the world needs, right? Towards the end of my master's degree, I realized that, there are very many applications of, in particular, computational mathematics, which means that, you use the computer to amalgamate it with mathematics and solve certain real world applications. With that, I wanted to move forward and build my research skill set and discern career options in particularly computational mathematics. And that's when I decided to pursue a PhD in applied mathematics with a focus in computational mathematics, and decided to move to the US to pursue that. So when now came the part where, I had to narrow down a focus on a certain application and find my advisor, right? So when I first time read a couple of publications from my advisor, who was Dr. John Zweig at the University of Texas at Dallas, it instantly drawn my attention, because his research had a lot of applications in medicine, astronomy, and optics as well. He was focusing his research on nonlinear optical dynamical systems. So that drew my attention. And, when he agreed upon, taking me up as one of his PhD students, I definitely jumped onto the opportunity. So my PhD dissertation focused on computation and stability analysis of periodically stationary pulses in a short pulse laser. To give a little more idea, because the audience is from a mathematical background here, during my dissertation research, what I did was I developed an efficient method based on the adjoint state optimization method to calculate these periodically stationary pulses, which are created by a short pulse laser. And then we wanted to also study their stability. And to do that, we used, or rather developed, a flow K theory based approach. And that is about my PhD research. So as I was earning my PhD, it not only helped me acquire some, problem solving skills and technical skills in mathematics, and in particular in computational mathematics, but it also really helped me develop some very important attributes that are, very unique to a researcher, such as like patience, curiosity, organization, time management, analytical thinking, and so on, right? And I did not know at that time that how important these attributes are if you are then jumping into, real world, finding different roles. So at this point in my career, I felt that I did have the right amount of skills and experiences that I can now start earning. Right now, it came to the professional side of the career. So then it makes it to the fourth component of ikigai, which is I am ready with the skill set. I need to find something where I could be paid for. And that's when I decided to take up an opportunity as a postdoctoral fellow at Houston Methodist Research Institute in Houston, Texas. At this point, I was little undecided on whether I wanted to continue my journey in academia or I wanted to go to industry. At that point thought that it would be a safer option for me to take up a postdoctoral position and, try to explore that path first. Here, in my postdoctoral fellowship, I developed mathematical models to test the efficacy of different cancer treatments. In this job, for the first time, I got a chance to work with hands-on real-world, data. I also fostered some new proficiencies like modeling a physical system, utilizing statistics to interpret this real-world data, and so on. But towards the end of my postdoctoral fellowship, I started to feel that, I am not really standing at the intersection of the four components that we talked about earlier. I was feeling that something was missing, right? And upon introspection, I realized that my propensity towards the use of computational mathematics, in particularly in the area of optics or related fields, was more. I also realized that I am highly motivated by immediately witnessing a practical implementation of my work. And that's when I finally decided that I want to make that transition from academia to industry. uh, this is the time when I got an opportunity to join Cadence, which is my current role as a lead software engineer. This was back in May 2023. So it's been almost 2 years now. Uh, in my current position, I am part of this R&D team for a leading circuit simulation software called Spectre. My day-to-day duties in this position are to develop, optimize, and code the numerical algorithms for radio frequency as well as optical circuits. As I said, it's been almost 2 years, and at this point in my career, I truly felt after making this shift that, I am indeed standing at the intersection of those four elements. So with that, I have shared my journey from making of the transition from academia to industry. Now let me give you a little bit more idea of what my current position is, and what the company does and how mathematics is important for this role. Okay, so Cadence's core business, apart from many other products, is what is called electronic design automation. In short, it's called EDA. Let me explain a little bit what EDA means, right? For a mathematical community, it could be a new concept. So, in our lifetime, we have seen this dramatical change, in our lives over the past 3 decades. We have seen a dramatic change the way the electronic devices have progressed in the couple of last decades, right? So many of us might have used some of these, and then these are the ones we are using now, correct? So how does EDA make an important role in this, progress of electronic devices? So did you know that, sand is turned into the electronic devices we use, right? So what happens in this process is that silicon is first extracted from the sand that can be then used to create the semiconductor wafers. These wafers are then sent to the what we call as fabs, where the semiconductor chips are manufactured. By turning these wafers into the integrated circuits, and then we use these, interesting devices that we use nowadays, correct? So where does EDA lie in this whole process? It lies in the middle of it. So now let's actually look at a proper definition of what EDA is. So EDA, or rather electronic design automation, is a collection of software, hardware, and processes that could help create complex electronic systems. EDA in particular helps in simulation, verification, prototyping, modeling of a certain design. And there are two main component of EDA, which is an integrated circuit and a PCB, which is called the printed circuit board. And these two together gives you the different products that we saw earlier. And as I said, my role is particularly in simulation of the integrated circuits, the ICs. So let me give you a little more idea of how mathematics comes into the picture of simulating these ICs. So we might remember the Kirchhoff's current law from our high school, maybe, or maybe from our undergrad, right? What it is, just to remind you, the algebraic sum of currents entering a node in a circuit is always zero, right? That's the Kirchhoff's law. When this is applied to each node of a certain circuit, it gives us an equation of this form: g of xt plus g times x of t plus c times x of t plus f of x dot t is b of t. Now, what all are these symbols are here? So x of t, of course, represents the vector of unknowns. It could be the voltages, for example. B of t would be the vector of inputs, for example, an input current. Then there is matrix G. This comes from the contribution of memoryless elements in a circuit, for example, a resistor. Then we have the matrix C. This is made up of all the memory elements of a circuit, maybe conductor or inductor. And finally, we have this nonlinear aspect as well, sometimes appearing in this equation. So this is how, of course, mathematics, let me go back to the previous slide once again to explain a little more. So this is how, of course, mathematics comes into the picture. Now here you see this equation in terms of, the time. We could also work on it in terms of frequency. There is another form of it called the state space form of this, equation to make it independent and so on, correct? Combining all these aspects, here are certain important areas of mathematics which I use in my day-to-day job at Cadence as a part of the circuit simulation team. First one, of course, is a differential equation. The second one is linear algebra. Then there is also Fourier analysis because, of course, when you are working in the frequency domain, that comes in handy. There is complex analysis. There is numerical methods because we quite often solve this type of equation, for example, using a finite difference method. And finally, the control theory as well. I talked about the state space model of the same equation that utilizes a lot of control theory. So here are certain areas that I keep using in my day-to-day job. So now that you know the kind of work I do daily in my current position, let me now talk a little bit about the transition that I made from academia to industry. What were the deciding factors, or what were the things I was worried about while I made that transition, correct? So first of all, what were the things that helped me make this transition smoother? Here are, if there are like people, who are about to graduate, or maybe you are still in your undergrad or in your graduate school, this might be sort of like tips for you. So first one coming from my side would be networking. Pay a huge attention to networking. Attend relevant conferences and corporate events as much as possible. Join extracurricular activity groups. There is, for example, Society for Industrial and Applied Mathematics, or there are many other societies, right? Join them. That will also help you build your network stronger, but it will also open other opportunities for you, correct? The second one is gather as much experience as possible. It could include like interning at certain company or a national lab, right? You could also explore some on-campus opportunities like being a TA, right? And if you are willing to find a job, particularly in a software industry, and if you have a good enough software skills, you could also participate in hackathons or other design contests. And finally, if you feel that you want to make a slight shift, for example, I did have a strong background in coding and mathematics, but I did not know a lot about for example, parallel computing. So I did go to certain online courses to build on that skill, and that did help me pass through the interviews, right? So if you feel that you want to build upon any new skill, of course, apart from the curriculum you have at your university, you could find other programs online. There are so many websites nowadays. So these were certain things that made my transition smoother. And finally, what were the things I was concerned about, and how my current company helped me overcome them. These are personal experiences very specific to my company, but I'm sure other companies are also offering certain programs like these. So the first one was imposter syndrome. One thing I did not mention is that I actually spent a very long time in academia. I also had a couple of teaching jobs back in my country. I was also assistant professor for a little while. Of course, I was a TA during my PhD. So most of my experience was that. So the first thing that hit me was, in fact, the imposter syndrome, right? I did not know if I was good enough. We always keep thinking this. How Cadence helped me here is that, first of all, they had a program called Career Catalyst program. It was actually, and it is defined to make your transition smoother from graduate school or undergraduate school to, industry. Through this program, what they offer is, they give you fundamentals of EDA. If you are not from this industry, they help you build different skills like collaboration skills, networking skills, speaking skills, time management, and whatnot. So that was the first thing that really helped me make this transition smoother. Plus, it helped me overcome my imposter syndrome. Of course, the manager and the team, they play a very huge role in making this transition smoother. And I personally got a really accommodative team where they were always there to help me out. And I'm sure this is the case with other companies too. The other thing was, I used to keep hearing a lot from my friends where they were struggling with work-life balance, particularly when they are working in a private industry, right? So that was another thing that I was concerned about. Now, Cadence in particular is it advocates work-life balance a lot. One of the things they do is they offer recharge days. For example, there is one today. So whenever there is like a holiday coming, for example, Monday is a holiday, so they would attach one more day as a recharge day, and it makes it a 4-day weekend, right, for us. So that's something that helps, even to do some miscellaneous work here and there on these holidays. It also organizes several events, celebrations of different cultures. There was a Chinese New Year a couple of weeks back, so we celebrated that. It just breaks that monotony of everyday life, and it gives you a refreshment. So that is something, these are the two things that really help me create a work life balance while working here. And finally, I was, as I said, my most of my experience has been in academia, and I was worried that I will miss teaching, I will miss mentoring, and other extracurricular activities that comes with an academic setup. So how Cadence helped me here was that Cadence organizes all these different volunteering events such as food drives, blood donation camps, and so on. Most importantly, there is a group at Cadence called Women at Cadence, and this gave me a lot of opportunities to go back to the teaching part. For example, right now through this Women at Cadence group, I have gotten an opportunity to be part of what is called as MIT Breakthrough Tech, where I am every month mentoring a group of 7 students. When they are at an intersection where they are planning to make a transition from whatever degree they are in to finding a job. So such opportunities I keep getting through Cadence, which is keeping the teacher in me alive and makes me feel better that I am kind of trying to balance both industrial life and at the same time enjoying the academic life as well. So yeah, these were three of my concerns before making that shift, and this is how my company in particular helped me transition through them. So yeah, that is the end of my presentation for today. And now if you all have any questions, if you want me to give you any details of maybe the things that I just briefly talked about, please let me know. And thank you so much for hearing once again.